Okay guys, so certainly you think I'm the best programmer on earth, but actually I'm not. Hey guys, how's it going? Today I will tell you the ultimate answer on the question you ever wanted to know in Java. The other day I was asked, hey Marcus, can you do please a video tutorial? How can I provide a strategy with an annotation? And I thought, why not? Let's do that on Saturday. It's a nice day, sunshine, so let's do that. Started programming and boom! It doesn't work the way I want it. So Java is a bit quirky when it comes to annotations, and it is a bit quirky when it comes to generics, and now we want to do both in one program, and this gets a little bit complex, but I made it. And so here is the final answer, because I googled for hours and didn't find the answer. So I hope you share this video with everybody you know, because it's really the ultimate answer. So here we go. Starting from hello world and an empty annotation, let me introduce what we actually like to do. The problem is that in some programs you like to annotate methods. For example, this one, it's providing a string, and it's called my method, and it does just something like return hello world. Okay, so we have here the string, my method, so you can follow that, I hope. And what people want to do is that they annotate this method and enable some kind of filtering using some magic like CDI, checks or S interceptors, whatever magic you can imagine of, or write their own annotation processes. For any case, they want to have an annotation here. So they say the result shall be filtered. So that's fine. And then they write an annotation processor. And there's a typo. Yeah, it's not static. Let's do it static. So there's still a typo. Yeah, sure. I have to remove this. Okay, so here we go. So this is the version not using the annotation at all. And they have some kind of magic, as I said, possibly checks or S interceptors, the CDI. And we fake this magic by simply using our own reflection API based code just to make clear what their problem is. So actually they check this annotation and they want to have an attribute here which defines how filtering does work. So in the first step, just let's do the filtering. So how could we do that? For example, we could obtain the annotation from the method. Get annotation. So let's simply throw everything. So it's just an example. In the end, we have our annotation at hand, which is filtered. And if you like, we could output it. So we see that at runtime the annotation really is here. Let's do that. Yeah, here's the annotation. So far so good. But they want an attribute. And to do that, we go here Certainly you know how to do attributes, but they want something special, and I will show you in a second. Let's say the attribute is of type string, and it provides the name of the filter. Filter name, and the default is, for example, my filter. Okay, so you can imagine what they are trying to do. They will ask for the filter name, for example. So if we start that, it tells us the default, and they may, for example, look up the filter name as a class. So they do class for name with exactly that. So let's put it here. And we can put it there. So actually we don't have this filter, so we should provide it. So let's, for example, do a sample filter here. I know it's a little bit long for the start of the video, but it is needed to make you understand their actual problem. So I call it my filter. So we have the filter here, and it has a filter method, string filter, takes input and does something with it. Filtered, for example, just to have something. So they could, for example, then invoke the actual, oops, sorry, forgot the typo, had crashing my filter. So here it is, yeah. So what they do is they create an instance of that. So they actually have a filter here. So we will perform the filtering. Oops. Filter and let's say the input, passing it. Next problem. A semicolon. Oh, my filter cannot be cast to. Oh, that's my fault. Sorry. My fingers are just. So I'm not. My fingers are just too quick. Okay, done. So we see filtered the input. So far, this is what all you can do right now to use strategies. You give the name of the strategy here. You look up the class, you create an instance, and you call a method of the instance, and you're fine. That's not a problem at all. The problem comes here. What I actually want to reach is they want to get rid of this string and replace it by an instance. But this is not possible in Java, unfortunately, because you only can have strings and basic types, but not any arbitrary type here. But you can have class here. So a first idea is let's give it the class. So the default could be my filter class then, and here we don't need the for name because we have the class directly in our hands now. So this is working actually. So let's do it here, and certainly we can now provide it explicitly in case we don't want to have the default, just by saying filter name is my filter class, and let's remove the default because we want to enforce that it's explicitly given. So this actually will work, as we can see here. But next problem, this class actually still is not type safe. And the question I should solve for them in my tutorial is to make it type safe. And really, I googled for hours and I did not find any example. Maybe I'm the first one providing an example for this. So let's see why they want it. Because this is an unsafe casting. So we can put anything here. I show you what their problem is. I put here, for example, number class. That would certainly fail. And they want to prevent this type of failure. Sorry. Let's return to my filter class. So how to do this type safe? This is the actual topic of the video. Sorry for being so verbose this time, but it's a really complex question and I need to have this set up. So now we have to set up and how we can fix it. I was such clever and I thought, well, shouldn't be the solution as easy as giving the type here. So for example, this should be some kind of interface. What could be the interface? Well, it's a simple filtering. So let's give function string to string. That looks as if it should work. So my filter itself will implement our interface. So let's say this is function string to string. Oops, sorry. Okay, seems like it should work. Let's move this here. I like these code completion things, but I have a new keyboard, so I'm a little bit bad in typing currently. So we have this one working, and now we need this one working. And this one says the method filter string is undefined. Yeah, this is apply. Okay, wow. And this is the point where I thought, well, why is that not working? And actually it says the type is mismatched. It cannot convert the class myFilter to the class function string to string. Well, sure, because this is my filter which implements function, so it's not an instance directly. How could we do that? And I tried and actually, I tried and actually I got an idea when I thought over the hierarchy of interfaces and classes that spans in memory. Maybe we should simply say that in filter name we just have something that is like a function. So it doesn't have to be exactly the function. And this actually made me happy. Ta-da! It's gone. Isn't that really cool? It's still working. So what we get back here, as you can see from this tooltip, it says we're getting back really a type safe member. So since it is type safe, we actually know for sure that the outcome of new instance will be really a function which maps string to string. So this is safe now. And this actually solves the problem they asked me. And finally, you have your tutorial here, even if it was not as smooth as I hoped it would be. But hey, I learned something after more than 25 years in Java, and I always liked doing things like this to provide annotations which allows you to say, hey, just apply some strategy on the result of my method, for example. There's going magic on in the background, like CDI or JAX-RS interceptors, and you have a type-safe way to really be sure not to give any crap by incident, but really provide only those implementations here that really can be used in the end in your code above. So let's run it once. This is the final output and it does what we like. We now can have a replacement, for example, let's say count chars, for example, and count chars will return the number of chars. So we have length here. And we just replace the strategy in a type safe way. That's the point. Now it is type safe. We can run it. No, guys, I have still made a failure. My God, this is the worst day of my life ever. Actually, it must be here. Function of string. I don't know, my brain is not working today. Actually, my brain is not working. Okay, now that's the point. I wanted to show you that now it is type safe. It simply uses this generic code so you can provide any filter strategy that you like. Yeah, now it's working. Sorry for me being silly. Counters. It works. Sorry. Okay, so you have the final answer now. How can I do strategies in a type-safe way with annotations? If you Google it and you don't find it, just look this video. Please share this video with everybody you think could use this in a Java program. With all your friends, with all your colleagues. Please give it a thumbs up. And never forget again, if you want to have a type-safe class inside of your annotation, then always provide $extends and it will work out of the box. See you soon, have fun, stay safe, and as always, party on! It's really the worst tutorial ever. I'm so silly dumb today.